States of matter. Gas. Science standards. 2.3, 3.3, 3.7, 5.7, and PS3. Click to continue.
Today we'll be talking about gases. And here's our weekly reader, States of Matter, Gases. This is Science WR down in the corner for weekly reader. Let's look at the back, get a sneak peek of what might be inside. Once again, it says, weekly reader, focus on reading. Did you know? Gas is a form of matter that is sometimes invisible. Breathing gases like air keeps us alive. Learn more inside. Here's the barcode. Guided reading, level M, running word count 753. That's for teachers to understand. All right, here's the title page. Weekly Reader, States of Matter, Gases, by Jim Mezzanotte. Table of Contents. Chapter 1, Gases All Around, page 4. Chapter 2, Properties of Gases, page 7. Chapter 3, Changing and Mixing, page 10. Chapter 4, Gases at Work, page 17. What did you learn? Page 22. Glossary, page 23. Index, page 24. Look at this picture over here. What do you think this might have to do with gases? Let's read the caption. Cover and title page. Many stoves use gas flames to cook food.
Click to continue.
Chapter 1, Gases All Around. Gases are a form of matter. Do you know what matter is? It is all around you. It is anything that takes up space and has weight. Mountains and oceans are matter. So is the air we breathe. Plants and animals are matter. People are too. Almost everything in the universe is matter. Matter can be in different forms or states. It can be a solid or a liquid. It can also be a gas. You can see solids and liquids. You cannot see most gases. Matter is made up of many tiny pieces. They are called molecules. In solids and liquids, they stay together. In gases, they do not. Instead, they fly around. They even hit each other. How can you hold a gas? You must keep it in a container. Look at that bold word, container. It means it's an important word. So gases you must keep it in a container. A gas always expands or spreads out. That's what expands mean. So, a gas always expands or spreads out to fill the container it is in. It will leak out if there is an opening. Gas spreads in all directions. So we've got a little picture diagram here showing us how gas molecules look. Let's read the caption. Gas molecules move in all directions. They always spread from one place to another. Okay, so we've got a label here that says molecule, so pointing at like a little molecule. Each of these little dots, these little blue dots, is a molecule. Gas molecules in a container. Now, next to each of these dots, there's a little white arrow that you might have trouble seeing, but they're all pointing in different directions, showing which direction the molecules are moving, because gas molecules are always moving around in all directions. So you got some molecules moving this direction, some going up this way. This molecule's got an arrow pointing in this direction. This molecule's got an arrow pointing in that direction. So they're all kind of bouncing around within that little box, that container we talked about. It says gas molecules in a container. So they're bouncing around in all different directions within that container, the little gas molecules. Normally they are too small to see, just to let you know. So this diagram actually makes the molecules extra big just for you to see. Molecule, once again, we have the blue dots showing the molecules and the little white arrows showing which directions the molecules are going. It says gas molecules spread out to fill a larger container. So this rectangle here, made up of two squares, represents one container that was the same size as this one up here, but that's been opened up. That's what this little line is. It's like a little door that opened up. So this little passage opened up between the two sides of the container, so they could spread out. And what you'll notice is that there's fewer dots in this one side of this container than there were in the original container of the same size. And they spread out evenly. There's about the same number of little molecules on this side, little blue dots on this side, as there are on this side, because gases will expand to fit the container that they're in. They'll expand out. So if you start with a bunch of molecules of gas in a container this size, and then open up a little door, all these little molecules will try to expand out, as long as there's nothing else out here trying to hold them in.
Click to continue.
Gases are all around. Did you ever feel a breeze? It is the air moving. Air is different gases mixed together. We need air to survive. Gases help us in many ways. Let's look at this picture. What's going on in this picture? Let's read the caption. On a windy day, you can see plants bend in the wind. This shows that air is moving. Air is made up of gases. So when plants bend in the wind, there's got to be something there pushing on them. Even if you can't see it, there's something there pushing on them to make them bend. And that thing that you can't see is a gas and gas molecules.
Click to continue.
Chapter 2, Properties of Gases. There are many different gases. How can we describe them? The ways we describe them are called properties. There's that word again. We saw this same word when we were talking about solids and liquids. Properties. Do you remember what properties means? Well, let's see. They'll probably give us some examples. All gases have weight. Weight is one property of gas. Air is a gas. Air has weight. How can we weigh the air? That's a good question. Let's see. Try this. Find a soccer ball. Let the air out and weigh it. Then fill it with air and weigh it again. The ball now weighs more. It has more air. The air has weight. So, look at the picture, see if it matches what you think they were describing. The empty ball has less air than the full ball, so it weighs less. Empty ball. See how it's deflated because there's no air in it, so it's all squished and small. Ball full of air. So that's a soccer ball you'd expect to see ready to play soccer with. Full of air, pumped full of air. And as you can see on this little balance here, since the ball full of air weighed more because it had air in it, it won the challenge of weight and pulled down because it's heavier than the empty ball and caused that side of the scale to pull up because it's lighter. Heavier with the air, lighter without the air. A gas can have volume. That must be another one of those properties. A gas can have volume. Volume is the space it fills. You can measure volume. A small container has less volume. A large one has more. What happens inside the container? Molecules bounce around. The bouncing creates pressure. Pressure is the gas pushing to get out. What's going on in this picture? What's the caption say? When you blow up a balloon, you give it more air pressure. Okay. So that's saying as you blow up the balloon, the gas that's now inside the balloon is pushing even harder to get back out. Because pressure is the gas pushing to get out.
Click to continue.
Chapter 3, Changing and Mixing. What if you kept filling a soccer ball with air? Think about it a moment. What would happen if you kept filling a soccer ball with air? After a while, the ball cannot get bigger, so its volume cannot change. How does more air fit inside? Good question. You are compressing the air. Let me read that again. You are compressing the air. You put more molecules in the same space. They bounce around more often, so there is more pressure. So Got a little diagram here describing what we just read. So let's read the caption. The ball on the right has more air molecules in the same space. This is what they're talking about right here. The ball on the right, lots of little dots. More molecules than the ball on the right. Just a few little dots representing a few air molecules. There is more pressure in the ball on the right than the ball on the left. So because this ball has more air molecules in it than this ball, it also has more pressure. Because they're all bouncing around more, meaning they're pressing against each other more to try to get out. It's like if you have a bunch of people, a bunch of kids in a little room, you know? You open that door, they'll all want to get out right away. Whereas if you just have a few kids in a room and you open the door, they're like, we're okay. We got enough space. We got enough space to run around and do our thing. You pack kids in a small room, you open the door, they're like, oh, freedom! Get out. Need more room to run around. We're tired of standing in one spot or sitting in one seat. It's one way to think of air molecules and pressure, or other gas molecules and pressure.
Click to continue.
Heat makes a gas expand. What if the gas is in a container? The container cannot get bigger. The volume does not change. Instead, the pressure changes. It increases. Whoa, have you ever seen anything like this before? What is it? In a pressure cooker, air cannot escape. As the heat rises, so does the pressure. The high pressure makes food quickly in a pressure cooker. All right. So that's one way to increase pressure, by heating up gas within a sealed container. Heat makes liquids evaporate or turn into gas. After a storm, rain produces... After a storm, rain puddles seem to disappear. The sun warms them. They turn into gas. This gas is called water vapor. Vapor. You cannot see it, but it is in the air. Let's look at this picture here. What does this look like to you? The sun warmed puddles on this sidewalk. After a while, they evaporated. So this liquid turned into a gas because it warmed up.
Click to continue.
Cold makes gas condense. Ooh, that's an interesting word. Let me start over. Cold makes gas condense or turn to liquid. That's what condense means. Turn to liquid. Have you ever seen dew in the morning? At night, the water vapor in the air got cooler. It turned to small drops of water. Some gases must get very cold to condense. This grass is covered with drops of dew. Dew is water vapor that turned into liquid. See all these little drops of dew? That's water that was once in the air as water vapor gas. But then as it cooled down, it turned back into a liquid. and landed, or I guess you could say condensed, on the grass itself. It's probably the grass that provided the cooling surface for that water vapor in the air. Gases can mix together. Air is a mixture of gases. It has oxygen. It has carbon dioxide. It has other gases too. A gas can also mix with a liquid. Air mixes in water. Fish take in air through gills. Did you ever see bubbles in fizzy soda? The soda has gas mixed in it. Some of the gas does not mix. It is in the bubbles. Soda bubbles have a gas in them. It is carbon dioxide. So the bubbles that you see in a soda, that's carbon dioxide that's been put in the soda. It's not regular air. Even though regular air does have carbon dioxide in it, the bubbles in soda are almost pure carbon dioxide. Much higher concentration than what's in the air that we breathe.
Click to continue.
Solids can mix with gases too. Did you ever see rust on a bike or car? Rust is metal, water, and the gas oxygen. The red areas on this car are rust. It is a gas mixed with a solid and a liquid. Now, I mentioned this in the, I believe it was the solids book when they were talking about solids mixing with gases. Now, technically, the gases do meet the metal and kind of mix with the molecules on the surface, but then as they mix with the molecules on the surface, those molecules actually become linked together and they become something entirely different. So you might have started with a steel molecule and an oxygen molecule, but after they kind of got close together, kind of mixed together, then they chemically combined and became an entirely new solid called rust. So I'm just clarifying that point a little more. Chapter 4, Gases at Work. Gases are important in many ways. Oxygen is a gas. We breathe in oxygen. We need it to live. Carbon dioxide is a gas. We breathe out carbon dioxide. It is poisonous to us. But plants need it to live. They create more oxygen for us to breathe. And we have a picture here. What does the caption read? Most plants take in carbon dioxide and give off oxygen gas.
Click to continue.
A gas is part of the water cycle. We mentioned that before when we talked about liquids. It's very important. All over Earth, water evaporates. It becomes water vapor, which is a gas. The sun warms the vapor, and it rises. Up in the sky, it gets cool and condenses. It forms clouds. Rain and snow fall from the clouds. So here's a little picture of the water cycle. Earth's water cycle never stops. During part of this cycle, liquid water turns to water vapor. So here's the liquid water in a river in the ocean. This is liquid water flowing, and as it flows from place to place, it's exposed to the sunlight. The sunlight warms it up, and that liquid water evaporates, becomes water vapor. So you see these molecules of water that are more spread out, of H2O, water, that are more spread out. They're not all close together like they were when they were liquid. They're spread out, and they rise up. And up here in the atmosphere, it's actually cooler, and they condense. Remember that word from earlier in the book? They turn back into a liquid, and they turn into little liquid droplets in the sky. Well, there's a bunch of wind and stuff way up high, so little tiny droplets of water can still stay up in the air. They're no longer a gas, but they can stay up in the air as clouds as long as the wind is strong enough and as long as the droplets stay small enough. But if those droplets start if you get two small droplets that come together and make a bigger droplet, that droplet is now heavier and harder for the wind to hold it up. And if you get big enough droplets, they can fall as rain, and we see raindrops on this side. Or if it's cold enough, those droplets can crystallize and turn to snow. And we've got snow show on this side of this arrow. So we got rain and snow on this arrow falling back down from the clouds. Liquid rain and solid snow. All made up of water molecules. How do you make a fire? You need oxygen. You must heat oxygen and a fuel such as wood. They form burning gas, the flame. Look at this fire down here. That's a big, hot looking fire. When wood and oxygen get very hot, they create fire.
Click to continue.
We can smell because of gas. A scent is really a gas. It spreads through the air to reach your nose. We hear because of gas too. What happens if you... Let me start the sentence again. What happens if you bang a drum? It makes air molecules move. They make other air molecules move. The moving air hits the inside of your ear. So look at this little picture down here. Gas molecules from flowers move through the air. When they reach your nose, you smell the flowers. Some gases are lighter than other gases. They have less weight. Helium is a gas. Helium is lighter than air. Helium can make a balloon float in the air. No matter where you go, gases are at work. They are a big part of our world. Look at this boy right here with a bunch of balloons. These balloons are filled with helium gas. The gas is lighter than air, so the balloons float.
Click to continue.
Okay. What did you learn? Question 1. How are gases different from the other two forms of matter, liquids and solids? Question 2. What happens when we heat gases? Glossary. Compressing means causing molecules in matter to be closer together. Condense, turn from a gas to a liquid. Container, something that can be used for holding other things. A container must be completely closed to hold a gas. Cycle, things happening again and again in the same order. Expands, spreads out. Liquid, a form of matter. A liquid cannot hold its own shape. Instead, it takes the shape of whatever holds it. Molecules, tiny pieces of matter. A molecule is two or more atoms joined together. Atoms are the building blocks of all matter. Pressure, the force of one thing pushing on another. A gas pushes against the inside of the container that is holding it. Properties, ways of describing something. Volume and mass are two properties of a gas. Solid, a form of matter. A solid can hold its own shape. This shape can be changed, but a solid will not change shape on its own. Vapor, something that is in a gas form. Volume, the space a gas takes up in a container, which is the amount of the gas. Weight, measuring the force of gravity on an object. Here's our index, which shows us which pages to find the various words on. So these are the words we can find in the book. Balloons, breezes, carbon dioxide, cold, compressing, condensing, containers, dew, evaporating, fire, gills, hearing, heat, helium, liquids, matter, metal, molecules, oxygen, pressure, properties, rain puddles, rust, smelling, soda, solids, sun, vapor, volume, water, water cycle, weight. Thank you very much.
Click to continue.
Thank you very much for participating in this lesson. Have a great day.